Section 7.2 is on multiplying and dividing rational expressions. Really, the problems end up looking very similar to the ones we saw in 7.1, where we're looking for things that are common factors on top and bottom that we can reduce by. The only difference is we're going to have multiple tops and bottoms as we multiply or divide these rational expressions. So, we're going to learn how to multiply rational expressions by polynomials, divide rational expressions, and convert units of measurement. In this section, we extend the rules for multiplying and dividing numerical fractions to problems involving multiplication and division of rational expressions. So for instance, when we normally multiply fractions, if we have 4 over 7 times 3 over 5, we multiply the 4 times 3 on top, we multiply the 7 times 5 on bottom, and we end up with 4 times 3 equals 12, 7 times 5 equals 35. When we get there, we need to check, is there anything that goes into both 12 and 35? There are no common factors, so this is the final finished form. We use the same procedure for rational expressions, where if we have two rational expressions, a over b and c over d, when we multiply them, the top becomes a times c, the bottom becomes b times d, and then we need to see if there's any way to reduce it. So, some examples here. If we multiply x over 3 times 2 over 5, 2 times x gives me 2x, 3 times 5 gives me 15. So this would end up being 2x over 15. For part B, 7 times negative 5 gives me negative 35. 9 times 3x gives me 27x. So I end up with negative 35 over 27x. In both these examples, there was no way to further reduce where I ended up. Here, if I do x squared times 3, I get 3x squared. 2 times y squared gives me 2y squared. So this becomes 3x squared over 2y squared. Finally, in part D, I have 8 times t minus 1 over t times t minus 2. Really, what I'd recommend for you guys when you're doing these problems is just to leave these as two factors being multiplied. So I would write it as 8 parentheses t minus 1 end parentheses over t parentheses t minus 2 end parentheses. It's possible that they will show going out a little further, where if I did this, I would do 8 times t is 8t, 8 times negative 1 is negative 8, and t times t is t squared, t times negative 2 is negative 2t. I prefer you to leave it as factors just so you can see what cancels. So, we're going to run through all these that I just said out loud, showing step by step how to get there. X times 2 over 3 times 5, that's how I wind up with 2x over 15. Again, it can't be reduced, so we move on to the next problem. 7 times negative 5 over 9 times 3x gives me negative 35 over 27x, which cannot be reduced. You do notice that they've said previously to bring that negative out front, so that's how they want them listed as answers. When we do x squared times 3, it becomes 3x squared. When we do 2 times y squared, it becomes 2y squared. Again, this cannot be reduced at all. This is where I would leave your finished form, 8 times t minus 1 over t times t minus 2. You'll notice they go the extra step of multiplying out. 8 times t gives them 8t, 8 times negative 1 gives them negative 8. When we multiply a rational expression by a polynomial, basically what that means is we're multiplying something that's as a fraction by some other term. So here we're multiplying 4 divided by x. Here we're multiplying 63x by 1 over 7x, and here we're multiplying 5a by 3a minus 1 over a. In each case, what we're really doing is assuming that the thing being multiplied is just divided by 1. So this 63x divided by 1, 5a divided by 1, x divided by 1. I can then do top times top, bottom times bottom, same way I did with fractions. So if I write this out as 4 over x times x over 1, the two x's in the problem are a common factor on top and bottom, so I can reduce them. That just leaves me with 4 over 1, or my final answer of 4. When I do this for 63x times 1 over 7x, it becomes 63x over 7x. The x's are a common factor that I can reduce, and also 63 can be written as 9 times 7. So once I write it as 9 times 7, I see that there's a 7 on top, a 7 on bottom. As I said, there's an x on top, x on bottom. So really all that's left on top is this 9. All that's left on bottom are the ones that get left over. So it becomes 9 divided by 1, which is just equal to 9. When I do 5a times 3a minus 1 over a, it becomes 5a over 1 times 3a minus 1 over a. Really, at this stage, I can see that there's an a as a factor on bottom and an a on top that can be reduced. Once I reduce those a's, it becomes 5 times 3a minus 1 over just 1. I could just write that as 5 times 3a minus 1. It's absolutely fine if you went the extra step and said, well, I could really multiply out. 5 times 3a gives me 15a. 5 times negative 1 gives me negative 5. But for me, on a test, I'd want you to leave it here. I believe that this answer is accepted in the online system, but they probably are going to show you the next step doing it out. So these example problems are a little harder than the ones that I just put up there. Basically, when I do these out, I'm going to want to multiply and see what factors go into the top, what factors go into the bottom, and then cancel out between the two. So for instance, this x squared plus 10x plus 25 becomes x plus 5, x plus 5. This x squared minus 9 becomes x plus 3x minus 3. I then would factor these bottoms, I'd cancel things out. What I'm going to do is I'm going to do these problems on the whiteboard. So you'll see in the video it's going to cut in, show me at the whiteboard doing these problems, and then I'm going to come back and go, well, the key to these more difficult multiplication problems is properly factoring first and getting rid of any factors that repeat on top and bottom, regardless of whether they come in the first fraction or the second fraction. So I'm going to do the factoring relatively quickly, knowing that you guys are factoring experts after last test. On top here, on the left, x squared plus 10x plus 25 factors to x plus 5 times x plus 5. On bottom, x squared plus 3x minus 18 factors to x plus 6, x minus 3. I'm multiplying that by x squared minus 9, which is a difference of squares, and becomes x plus 3, x minus 3, over x squared minus 25, also a difference of squares, x plus 5, x minus 5. When I do this out, I have an x plus 5 on top, x plus 5 on bottom that I can get rid of. I have an x minus 3 on bottom and x minus 3 on top that I can get rid of. Everything else has to stay in the problem. So when I multiply through, on top I have a leftover x plus 5 being multiplied by a leftover x plus 3. On bottom I have x plus 6 being multiplied by x minus 5. I believe the system will let you leave it right here. If I was giving a test that I was grading by hand, I would absolutely want you to leave it right here. That said, I always can multiply back out using double distribution in order to get it into trinomial form. In order to do that, I do x times x gives me x squared. 5 times x is 5x, plus 3 times x is 3x, for a total of 8x, and then 5 times 3 is 15. Over x times x is x squared, 6 times x is 6x, minus 5x leaves me with just positive 1x, and then positive 6 and negative 5 combine to give me, or multiply I should say, to give me negative 30. So I'm guessing that the system is going to show you this as the correct answer, but would still accept this, where you don't have to multiply it out. That said, they might make you go to this extra step of multiplying it out. For the rest of these problems, I'm just going to stop here, knowing that you'd be able to multiply them out if you had to. So for part B here, x squared minus 5x minus 6, I can factor that into x minus 6, x plus 1. 9x squared plus 27x, I can take a 9x out of. That's going to leave me with x plus 3.
I'm then multiplying that by, on top of the fraction, x squared plus 7x plus 12 becomes x plus 4, x plus 3. And on bottom, x squared plus 5x plus 4 becomes x plus 4, x plus 1. I can then reduce this x plus 1 with this x plus 1, this x plus 4 with this x plus 4, this x plus 3 with this x plus 3. That leaves me with the final answer, only x minus 6 on top and 9x on bottom. In part C, I can't really factor x minus 7 any further, so I'm just going to leave it as x minus 7. Because I see I've got a 35 here and a 10 here, I'm going to change this from a 10 to 2 times 5, x to the 6th. This is now being multiplied by, on top, 35, I'm going to change to 7 times 5, x to the 8th, divided by x squared minus 49, which is a difference of squares. I can call x plus 7, x minus 7. I can then see the repeated factor of x minus 7, the repeated factor of 5. When I look at the powers of x, I've got x to the 8th on top, x to the 6th on bottom. That means there's 2 more on top, meaning x to the 2nd is left over. I cannot reduce this any further, so on top I have 7 times x squared, which gives me 7x squared. On bottom I have 2 times x plus 7, which I'm just going to leave as 2 times x plus 7. Part D, start out factoring the top of this one, x squared plus 3x plus 2 becomes x plus 2, x plus 1. On bottom, x squared plus 2x plus 1 is just x plus 1 times x plus 1. I'm then multiplying that by x squared minus 1, which is the difference of squares, x plus 1, x minus 1, over x squared minus x minus 2, which is x minus 2, x plus 1. If I now try and reduce everything that can be reduced, this x plus 1 and this x plus 1 can go, this x plus 1 and this x plus 1 can go. Here I have an x minus 1 left over that can't cancel with anything below it. I have an x plus 2 left over that can't cancel with anything below it. So in the end, I'm just left with on top x plus 2, x minus 1, and on bottom, I have x minus 2, x plus 1.
Basically the same idea as multiplying. The key distinction is where I used to have a division symbol, I need to change it to multiplication by showing the reciprocal of the second fraction, the one after the division symbol. When I say reciprocal, I mean what was on top goes to bottom, what was on bottom comes to the top. I then multiply tops, 4 times 5 gives me 20. I multiply bottoms, 7 times 3 gives me 21. So it's the same process once I flipped the second fraction. In the end, as long as I know d doesn't equal 0, a over b divided by c over d just becomes a over b times the reciprocal d over c. So if I had to divide a over 13 divided by 17 over 26, I'd really multiply by 26 over 17. If I had divide negative 9x over 35y by 15x squared over 14, I'd really multiply by 14 over 15x squared. So here when I multiply by 26 over 17, hopefully before I do the multiplication I see, well, 13 and 26 both have the common factor 13. I can get rid of this 13, I can make this 26 into a 2. Then it becomes a times 2 over 17, which just gives me 2a over 17. Here they've written out the factors so that you can see these 13s will cancel to leave me with 2a over 17. Here, once I flipped 14 over 15x squared, I see that there's an x that can go into both this and this, so that would just leave me with 15x on the bottom. It would leave me with just negative 9 on top. I also see that 35 and 14 share the common factor 7, and 9 and 15 share the common factor 3. Really what I want to do is I want to reduce by that common factor before I then multiply and find what's left. So you'll see that they write out all the factors here on top. This negative 9x becomes negative 3 times x. This 14 becomes 2 times 7. This 35y becomes 5 times y, 7 times y. This 15x squared becomes 3 times 5 times x. So I can reduce x with x. I can reduce 3 with 3. I can reduce 7 with 7. What I'm then left with is on top a 3 and a 2. When they multiply, they give me 6. On bottom, a 5, a y, a 5, and an x. When I multiply, that gives me 25xy. So my final answer is negative 6 over 25xy. To divide a rational expression by a polynomial, we write the polynomial as a fraction by inserting a denominator of 1. Then when we divide, we flip it so it becomes 1 over the polynomial. These are the last examples, which again I'm going to do out on the whiteboard. All that's happening here is that I'm going to factor just like I did with multiplication. The difference being that when I go to see what reduces, I make sure to flip the fraction after the dividing line. When I go to divide these problems, basically where I'm going to begin is by rewriting the first fraction, top over bottom. So x minus 8 over 18x to the 5th. I'm then going to write in a multiplication symbol, and I'm going to write what was on bottom, on top, 27x to the 4th. Then I'm going to write the factored form of x squared minus 9x plus 8 on bottom. So this will have two parentheses, x and x. I'm going to bring down this negative sign to the first parentheses. That positive sign tells me same, so this will also have a negative sign. What multiplies to 8 and adds to 9? Well, the ways to multiply to 8 are 1 times 8 and 2 times 4. 1 plus 8 gives me 9, 2 plus 4 gives me 6. This is the one I'm looking for, so I put the larger one there, the smaller one there. I then can see that x minus 8 is a repeated factor that can go away. I also can see that I have x to the 4th on top, x to the 5th on bottom. That means I can get rid of 4 on top, get rid of 4 on bottom, and I'm just left with x to the 1st. When I now see 27 and 18, I can rewrite these as 9 times 3 and 9 times 2. The factor of 9 can also cancel. That means on top, the only thing left over is that 3. On bottom, I have this 2 times this x minus 1. So I'm going to write that as 2x times x minus 1. When I get to part B, again, I'm going to rewrite the first fraction, x minus 3 over 14x to the 8th. I'm going to put a multiplication symbol. What was on bottom goes to the top, 28x to the 10th. What was on top goes to the bottom. I'm going to write it in its factored form. So in this case, x squared minus 13x plus 30 starts with an x and an x. I'm going to bring down that negative. That positive tells me same. Same as a negative is another negative. I'm looking for two things that multiply to 30 and add to 13. The ways to multiply to 30 are 1 times 30, 2 times 15, 3 times 10, and 6 times 5. The one that adds to 13 is 3 and 10, so I'm going to put the larger one here, the smaller one here. When I now go to reduce, this x minus 3 and this x minus 3 is a repeated factor, top and bottom that can be reduced. Here I have x to the 8th, here I have x to the 10th. If I get rid of x to the 8th from each of them, that leaves 2 left over on top. I could rewrite this 14 as 14 times 1. I can rewrite this 28 as 14 times 2. I can then reduce the 14s. On top, I'm left with 2 times x squared, which gives me 2x squared. On bottom, I'm left with x minus 10 times 1, so I can just write it as x minus 10. So my final answer for that problem is 2x squared over x minus 10.
For part C, again, I'm going to rewrite on top x minus 5. As I write the bottom here, x squared plus 4x, I see that I can factor it by taking out the greatest common factor of x. If I take out that x, it leaves behind x plus 4. I then write my multiplication symbol. I take what was on bottom to the top, 6x to the third, and on bottom I'm going to factor this. So I have two parentheses. I need to put in x and x. This tells me that the first sign is negative. That positive means same, so the second sign is also negative. I'm now looking for two things that multiply to 40 and add to 13. The ways to multiply to 40 are 140, 220, 3 doesn't go in, 4 does, 410, 5, 8. The one that adds to 13 is 5 and 8. So I put the larger one here, the smaller one here. This repeated factor of x minus 5 can go away. This x in front can reduce this x to the third to an x to the second. Nothing else can be reduced, so on top we have 6 times x to the second, or 6x squared. On bottom we have x plus 4 times x minus 8. I'd rather you leave it like this. If you see the answer in Cengage, they probably multiply out these two factors and make it into a trinomial, but I really think you're better off leaving it right here, and I'm pretty sure the system will accept that answer. For part D, I'm going to rewrite x plus 4 on top, on bottom 40x to the second. I'm then going to make it a multiplication symbol. What used to be on bottom goes to the top, 10x to the 7th. What used to be on top goes to the bottom. I'm going to write the factored form with two parentheses, x and x. First sign's positive, I bring it down. Same as first sign would also be positive. I'm now looking for things that multiply to 28 and add to 11. Ways to multiply to 28 are 1, 28, 2, 14, and 4, 7. 4 plus 7 gives me 11, so I'm going to write the larger one here, the smaller one here. I then see that x plus 4 is a repeated factor. I see that 10 can go into both 10 and 40, so I could write this as 4 times 10. That way this 10 and this 10 could be reduced. I have x squared here, x to the 7th here. That means I have 5 more on top. So what's left over on top is x to the 5th. As I now multiply across, the only thing left on top is that x to the 5th. On bottom I have this 4 times this x plus 7. So I'm left with 4 parentheses, x plus 7. Again, you could distribute that 4, but I'd say probably you don't need to. I think it would accept it just like this.